Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we'll be looking at the most repeated non-calculated questions from Edexcel past papers. So if you're interested to know what some of the topics are that we'll be looking at, then there's a list here that you can pause to read through. So we'll be starting off with some of the slightly easier questions and then working our way up to some of the harder ones towards the end. For each of these questions, you can find its original paper listed in the top right-hand corner if you want to go and have a look at that, or the mark scheme. So multiplying and dividing decimals is a really big topic that comes up in non-calculator papers, obviously because it's quite hard to do without a calculator. So multiplying decimals, all I do is just make both of them whole numbers, whether that's multiplying by 10, 100, 1000, just depends on the question. So I'm going to start with that. As you can see, I just need to multiply by 100 on the first number, which will give me 367. And then I just need to multiply by 10 on the second number to give me 42. So now my calculation is obviously 367 times 42. Now in this case, I am going to use column multiplication to actually work that out. Starting off with the 2, and column multiplication is obviously a really good skill to have for your non-calculated paper generally as well, so make sure you remember how to do that. So 2 times 7, 14, carry the 1. 2 times 6 is 12, add 1, 13, so carry another 1. 2 times 3, 6, add 1, 7. Now, because we're dealing with not just 4, but 40, we have to put 0. And then do the same. So 4 times 7 is 28, carry the 2. 4 times 6 is 24, so add 2, that's 26. Obviously carry the 2 again. And then 4 times 3 is 12, add 2 is 14. Now we just need to add together these two rows. So we've got 4, 11, that's 13, plus 1 is 14, 5 and 1. Now obviously 15,414 isn't the actual final answer, those are just the correct digits. We need to then figure out actually what scale it is. So you've got two options. Either you can just look at 3 times 4, well that's 12, so this will probably be around the same scale, so probably 15. Or based on how many times we multiplied originally, to see how we changed the decimal place by 2 here and by 1 here, that's 3 times in total, or by 1,000. I then need to divide by 1,000, or in other words, move the decimal place 3 times back. So 1, 2, 3. So you can see either way you should get 15.414. There was also a part B to this question where they wanted you to divide. So work out 59.84 divided by 1.6. So in this case, with divide, you can do the same and just make them both whole numbers, but I'm going to look at it a bit more specifically. I'm going to change them both by the same amount. So I'm going to move the decimal place by the same number of times, or I'm going to times by either both by 10, both by 100, or whatever it is. In this case, obviously, I need to change the first one by 100. So I am actually also going to change the second one by 100 as well. The reason why I've done this is because when I divide them, if I change them by the same scale, then the answer is the same. I don't need to scale it back afterwards. So I'm going to have 5,984 and then divided not by 16 but by 160. So obviously that doesn't go into 5, doesn't go into 59, so I'm going to go straight into 598. I would actually recommend for the non-calculated paper to recognise or just be a bit more familiar with some of the 15 and 16 times tables, so maybe up to like 5 or 6 times 15, 5 or 6 times 16. Obviously in this case it's 160, so that helps as well. So I know that it goes into 640 4 times, but that's too big. So the one before that would be 480 3 times. So 3 would go here. Now the difference between 480 and 598 is 118. So then my remainder was 118 there, but obviously there was still a 4 here, wasn't there? So now that's 1,184 divided by 160. So I know that it goes in 7 times, it goes into 1,120, then there's a remainder of 64. Now obviously that 64 gets carried over into my decimals, so there's a 0 here. Now it's 640, which is perfect. We just mentioned that obviously 16 goes into 64 4 times, so that's the same for 160 into 640. And there's no remainder, so that's it. 37.4. So I didn't have to scale it back in the end. It only works with dividing, but with dividing, if you change the original numbers by the same scale, so both by 10, both by 100, both by 1,000, whatever it is, then the answer is the same. Okay, question 2. The next topic is fractions operations, so adding, subtracting, multiplying, dividing, and in particular, when you've got mixed numbers. So we've got to work out 1 3/5 add 2 1/4, give your answer as a mixed number, When you add and subtract mixed numbers, you can just add and subtract the whole numbers and then add and subtract the fractions separately if you want. That would mean that the fractions would stay quite small, might be easier to work with when you obviously have to find a common denominator. However, the other thing to consider is when you're multiplying or dividing with mixed numbers, you do have to convert them into improper fractions. So you might prefer to go, do you know what, I'm not going to try and remember two methods. I'm just going to remember any type of fractions operations. I'm going to convert them all into improper fractions, and then, if necessary, convert back at the end. It's up to you. You've got those two options. So I'm going to convert them and just show you if you want to make them into improper fractions. So converting, we obviously also then need to know how to convert between mixed numbers and improper fractions both ways. So a mixed number into an improper fraction, you take the whole number, multiply by the denominator, so that's 5. Add the numerator as kind of a remainder, so that would be 8 fifths. And then the same here, 2 times 4 is 8, plus 1 is 9 quarters. Now, when I add them, I do obviously need to have a common denominator. So the lowest common multiple of 4 and 5 is 20, so I need to change both fractions. The first one I need to multiply by 4, so that's 32 over 20, and the second one by 5, 45 over 20. Then we only add the numerators, so that's 77 over 20. You might want to check if you can simplify your answer. In this case we can't, but just double check in the question you've got. And then it does say give it as a mixed number, so I now need to convert it back if you've done this method. So then you say, well, how many of my denominator goes into the numerator? A whole number of times. So for example, 20 goes into 77 3 times whole, so that would be 60. And then the remainder, which is 17, would be your numerator. So the answer to this one particularly is 3 and 17 twentieths. There was also a part B, which is now dividing, so show that 2 and 2/3 divided by 6 as a whole number equals 4/9. So first of all, I do actually have to change 2 and 2/3 into an improper fraction. I don't have a choice here, so 2 times 3 is 6, add 2 is 8, so 8/3. Then dividing by a whole number, I just like to make it into a fraction. So any whole number, if you put it over 1, becomes a fraction. Now obviously there with divide, we know we need to do keep, flip, change. So keep the first fraction, flip the second, and change it to a multiply. And then you multiply straight across. So 8 over 18. And they've said show that it's 4/9. Well, that's just the simplified version, isn't it? Question 3, another super popular question, is write 156 as a product of its prime factors. So break it down with a prime factor tree. Some people break it down into any factors and then just make sure they're prime at the end. I like to just start straight away with prime factors. So for example, I normally start with 2 just to keep halving any even numbers until they're odd. If they're then odd, I look at 3 and 5 or any other possibilities. So in this case, I'm just going to half it. So that'd be 75 plus 3, which is 78. Still even, so I'm going to half it again. 35 plus 4 is 39. Now it's odd. So now I'm going to look 3 or possibly 5. In this case, obviously 3. And the other one would be 13, which in itself is a prime factor, isn't it? So these are all my prime factors. All the ones on the left and then the one obviously at the end. So now I can write it as 2 times 2 times 3 times 13, because product is just another way of saying multiply. And in other words, if you need to write it in index form, or if you just want to, you can write 2 squared, because that's repeated, times 3 times 13. Following on from that, we need to then find the highest common factor of 156 and 130. So I've written down the product of prime factors of 156, which you would obviously see on your exam paper, on your previous question. And I also need to do, therefore, a tree for 130. So again, 2 because it's even. Now it's straight away odd. I actually can see that 5 would obviously go into that by 13, and then 13 again is a prime number. The way that I like to work this out is obviously with the Venn diagram method. So just scribble 2 circles, and for the highest common factor we just fill in the middle, so that would be the numbers that they have in common. Do you see how they both have 2? So where we have a pair of 2's in common, we just write it once, and then also they both have a 13. So I'm going to write that. Technically you would fill in the rest of the Venn diagram if you wanted to, and specifically if you need to know the lowest common multiple, but the highest common factor is just this bit here in the middle. So you just need to multiply together, in this case, 2 and 13. For the lowest common multiple, you multiply together the whole Venn diagram. So it should be 26. Okay, we also need to know how to work with percentages when we don't have a calculator, but more specifically what we call reverse percentages. Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. So that is the price of the machine plus the VAT, which is a form of tax. What is the price of the washing machine with no VAT? So do you see how that's previous? So they've taken the price of the washing machine, they've added 20%, it equals 600. We want to go backwards in time to before they added 20% VAT. So that is reversing it, isn't it? Now, it's not 20% of 600. That's the mistake that a lot of people make. They think, oh, 20% of 600, I just need to reduce it by 20%. No, it was 20% of the original price that was added, and then it equals 600. So 600, very important to identify what percentage that represents. That represents 120% of the original price without the VAT. Now, normally, if I had a calculator, I would just divide this by 120% as a decimal. And I guess you could technically do that if you really wanted to divide by a decimal. You could also use bus stop and work it out that way. But I think an easier way when you've got no calculator is to go, right, I want to find the original price, so I need to find what 100% is. How do I go from 120 to 100? One way, I was thinking, you could obviously either divide by 12 to get 10% and then times it by 10, or you could divide by 6 to get 20% and times it by 5. It's up to you. I think I would divide by 6 just because that would be easier for 600 divided by 6 than 600 divided by 12, but you can do either. 600 divided by 6 would obviously give me 100, and that is then equal to, because 120 also divided by 6 would give me 20%. So again, 20% of the original price. How do I go from 20% to 100? Well, I then would need to multiply by 5. So also, obviously, therefore, I need to multiply the £100 by 5. So my answer would be 500. That's how I would do it. If I had a calculator, I would just do 600 divided by 1.2. Or as it says, you can actually use that with bus stop if you prefer. So do you see how the 20% was actually 20% of 500 added on to 500? It wasn't 20% of 600. So that's the thing, is when to identify that it's reverse percentages as well. Okay, so cumulative frequency will obviously pretty much always come up in one of the papers, but I feel like it's quite common to come up in the non-calculator paper. So we've got question 10. The table shows some information about the profit made each day at a cricket club on 100 days. So you've obviously got your frequency table here. Part A is complete the cumulative frequency table for 1 mark. This is so easy. All you have to do is just add up the numbers. So obviously the first one is still 10, but then the second row includes the first and second row. So that'd be 25. And then the third row includes the first 3 rows. So each time you're adding more. So add another 25 is 50, add 30 is 80, add 5 is 85, and obviously your final number should add up to, if they've told you in the question, it should add up to the same total amount. That's it for the table, super straightforward. Now I've copied the table over here, because then part B is normally to plot this on the graph. So all we need to know is, in terms of these ranges, which numbers are we plotting? It's always the right-hand side. Always the right-hand side, okay? So I just need to plot 50 along, and then 10 up. Be careful of the scale, sometimes the scale's a bit difficult. 125, so that's 30, so it'd be halfway. 150, 50, that's here. Obviously it should always be increasing, this graph. 200 at 80, 250 at 85, so halfway again, and then up to 100. And now obviously you're going to join it up, but try and join it up with some kind of slight curve. Obviously yours should hopefully look a little bit nicer than that, but that's 2 marks. So currently we've already got 3 marks for just doing a table and filling it in. Now, there's normally some kind of part C or part D as well. So here we've got part C. Use your graph to find an estimate for the number of days on which the profit was less than £125. So come back here. The value we've been given is £125. So obviously that's on the x-axis, isn't it? I need to find 125, which is halfway between these, which is here, and then draw a line up until it hits my curve, and then draw the line across to the cumulative frequency axis. So yours might obviously look different. Mine came out at 40. Yours would obviously hopefully come out somewhere around that point. It might be slightly different though, that's fine. Normally there's a slight range of possible answers because everyone's curve will be slightly different. So I'm going to write that. Now it says less than 125, so 40 days would be fine. If it said more than 125, because 125 to 0 is this part here, isn't it? Which is therefore up to 40, isn't it? 40 days. Now, if they did say they wanted above or more than 125, which also does happen, they would be looking at 125 and above. Do you see how that would be this part of the graph? which means it's from 40 up to your total, in this case 100. So actually, if they said greater than £125, it would be 60 days. So just be careful if they said above or below, greater or less than, bigger or smaller, whatever it is. Now, part D is then to use your graph to find an estimate for the interquartile range. This is the other type of question they could ask. So the interquartile range, we should have this obviously memorized. Know what this is the upper quartile minus the lower quartile. So I need to work out two figures. Now the upper quartile is always 75% of the total frequency, right? Frequency. So now we're looking at the y-axis, and the lower quartile is 25%. So either that you can think of it as that, or you can think of it as 3/4 and 1/4. That's fine. So my total frequency was 100, wasn't it? So for the lower quartile, 25% or 1/4 of 100 is obviously 25. So I'm going to draw my line from the y-axis now. Now we're doing it differently, from the y-axis at 25. Again, be careful where the scale is, because 25 is not this middle point here. It's actually halfway like this, and then down. Now, 25 was actually one of the numbers here, wasn't it? So you can see that that's clearly 100. Everyone should get 100 for that one because it was an exact point. And then 75% of 100, or 3/4, is obviously 75. So again, so this is 70 and then 75 across and then down. So we've got to be careful of the scale again, haven't we? I know that that's 175. So that should be 190. That's what I got, 190. So I got 100 and 190. So 190 minus 100, we actually do have to calculate that. The interquartile range is 90 because our answer was in pounds. So we had to come from the y-axis across and down to read off of the x-axis. This part D works the exact same for the median. The median is just 50% of the total frequency. Otherwise, it's the same. Okay, the other thing they could ask, which is kind of in the same topic, is box plots. So we need to know how to plot a box plot. So the table gives some information about the heights of 80 girls. You should have 5 pieces of information. The least, the greatest, the lower quartile, the upper quartile, and then the median. So here they've given us that perfectly in the table. Sometimes it might not be as obvious. Sometimes they might give you a range or an interquartile range. You have to then figure out these figures. So let's just draw vertical lines for each of these. Obviously, again, be careful of the scale. This is quite straightforward scale though, so this one should be okay. So the least height is 33, then the greatest 170, then we've got lower quartile 145, upper quartile 157, and finally the median is 151. Now the 3 in the middle you can create a box with, and then the 2 on the outside just join up as if they were kind of whiskers. So there's your box plot. 3 marks, that's really straightforward. There is also a part B. Work out an estimate for the number of these girls with a height between 133 and 157. So I've got the table here again just so you can look at those numbers. They've chosen them specifically. Do you see how 133 is the least height and 157 is the upper quartile? They will only ever choose numbers in this type of question from your table. Now coming back to what we said about the upper quartile, that is 75% of the data from the least height, so that's the lowest number, the smallest number, up to the upper quartile, is 75% of the data. They told us that there were 80 girls. So I just need to know, they said the number of girls between these two, well that's obviously 75% of 80. Now it is non-calculator, so you can either work out 3/4, or you can figure it out by doing 10%, 5%, all of that. Personally, I'm going to do 3/4, which I can divide by 4 to get 1/4 is obviously 20. And times by 3 to get 3/4, which is 60. 60 girls. So they'll only choose numbers from this table. They won't just use random numbers. So now looking at index laws and negative and fractional indices. So this one comes up a lot. Write down the value of 7 to the power of 0. So not necessarily 7, just any number, sometimes a letter to the power of 0. It's always 1. You just have to memorize that. Anything to the power of 0 is 1. Part B, find the value of 3 times 3 to the power of 6 times 3 to the power of minus 6. Now, they don't want you to literally work out 3 to the power of 6 as numbers and then multiply them all together because that would just be such a huge number. So I'm going to use indexed laws. This 3 here is technically the power of 1. When we're multiplying and they all have the same base number, 3, 3, 3, I just need to add the powers. So that's 1 plus 6, which is 7, minus 6, which is 1 again. So these basically cancel out, don't they? The value is just 3. So a bit of a trick question. Part C, find the value of 2 to the power of minus 4. Now you just have to memorize what a negative power means. The negative means the reciprocal. So 2 currently is 2 over 1. We just don't normally write the 1. So therefore the reciprocal is when you flip it, is a half. Now the other thing though is that you do then have to obviously do it to the power of 4. So 1 to the power of 4 is obviously just 1. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So it's 1/16. And finally, part D, find the value of 27 to the power of a third. Now, fractional indices, the denominator means some kind of root. So that obviously means a cube root. They won't make you square root or cube root or any type of root, any numbers that aren't already square or cube numbers in the first place, right? They're not going to make you physically work it out. You should just be able to memorize it. So I know that the cube root of 27 is 3. I just know that, right? That's just information. I didn't actually try and calculate it. So that's an easy 4 marks. We've got another index laws question here. They've obviously just included some algebra as well. So I'm going to deal with the numerator first. That's our third index law. The one with the brackets, that's when you multiply the powers. Now, the x and the y are pretty straightforward. It's more the 6 that students don't necessarily know what to do with. It's powers that we're multiplying. So we're not going to do 2 times 6. Everything in those brackets is squared, right? So the 6 is currently to the power of 1. Do you see how that would be then 6 squared? Because I'm doing 2 times 1. So 6 squared is 36. You can actually work that out. Then we've got x to the power of 5 times that by 2. So that's x to the power of 10. And the same with the y. 3 times 2 is 6. So I've just multiplied all the powers by 2, basically. Now the denominator is basically the one we just did, where you're multiplying, so you actually add the powers. However, again, these numbers at the front, 3 and 4, that's not related to index laws because they're different numbers, aren't they? That is just 3 times 4, literally. So that's 12. And then when I look at the x's and then I look at the y's, that's when the index laws come into it. So I've got x squared, and then this is technically x to the power of 1, isn't it? So x squared times x is obviously x cubed, add the powers. And then y to the power of 7 times y to the power of minus 3, I need to add 7 plus minus 3, which is y to the power of 4. So that's the first step. But they've told me that I can actually write it in this format, not a fraction anymore. So I'm going to go through and divide. Now, again, 36, 12, they're just numbers. They're not anything to do with index laws, so those I do need to divide. So 36 divided by 12 is obviously 3. Now looking at the x's, I can use my index law where it says to divide, we actually have to subtract. 10 minus 3 is 7, and then the same with y, 6 minus 4 is 2. Now do you see that's in the format that they wanted? 3x to the power of 7, y squared. Now we've got a harder one with negative and fractional indices again. So 27 to the power of 2/3, we said before that the denominator is the type of root. So that's the cube root of 27. Now this one does have a 2 though in the numerator. So you would apply that as a normal power. So that would obviously be cube root is 3 squared 9. Then the second bit, we said the negative power is the reciprocal. In this case, we're then flipping it back again, so it would become technically 2 over 1, which is the same as saying just 2, isn't it? 2 divided by 1 is 2. So that becomes 2, but then I still have to do to the power of 3, 2 cubed. Right there, 2 cubed, so that's plus 8. And then in this case, they've said work out the value, so I do need to add those. So that would be 17. If you memorize this, it'll be really straightforward in the exam. Okay, our last one in indices, but this is a much harder one. So given that 9 to the power of -1/2 equals 27 to the power of 1/4 divided by 3 to the power of x plus 1, find the exact value of x. So here, the thing to note, because as I said before, you're not going to square root, cube root, or anything, any type of root, numbers that aren't square, cubed, or anything. In this case, it's technically the 4th root, but that doesn't work with 27, does it? So I'm not actually going to work it out in the same way as before. I just need to recognise that all 3 of these are some version of a multiple of 3, aren't they? 3 squared, 3 cubed, just 3. So I'm going to rewrite them with 3 as the base so that I can then use index laws. So 9 is 3 squared, and then in this case they have actually put it to power of -1/2, so that's still there, and then 27 is 3 cubed. So I'm kind of substituting that in instead of the 27, and then it's still to the power of 1/4. Now the last one I don't need to change, it's already in terms of 3. Obviously now I've got my index laws, which is the one with brackets, so multiply the powers. So you see how we've got here, 2 times -1/2 is just -1. And then 3 times 1/4 is obviously then 3/4. And I'm obviously not going to work out, again, as I said, the 4th root of 3, because I don't know what that is. Divided by, the other one is still the same, 3 to the power of x plus 1. Now do you see here, they've both got 3 as the base number, and it's a divide. So I can actually combine those. So leave that as 3 to the power of -1. We've got then 3/4, subtract both of these. Subtract x, subtract 1. Because divide means subtract. Now, if you actually simplify that, 3/4 minus 1 is minus 1/4, isn't it? So I'm just going to rewrite that just so we've got it simplified. Minus 1/4. Now, what you're aiming for is to get, in this case it was the base number was 3, sometimes it's 2, but you want to just get one version of the base number on each side. So you have got 3 to the power minus 1 on one side, and on the other side, 3 to the power of minus 1/4 minus x. We're saying that 3 to the power of something is equal to 3 to the power of something else. Well, then these powers must be equal, mustn't they? Because the base number is the same. So I can ignore the base number now and go, right, now I can create an equation with just the powers, which is an equation with just x. So they're basically saying work out where x is. I can do that now. So now I'm going to solve it. I'm going to add x, and I'm going to add 1. X is 3/4. Okay, so the next topic is algebraic proof. So prove that the square of an odd number is always one more than a multiple of 4. Now that's a lot to take in. I always like to split my proof questions into 3 sections. So the first thing is, what type of number are they asking for? They're asking for an odd number. So I need to do algebraically an odd number. I can't just pick a random odd number because then it's only proving it for one odd number, not all of the odd numbers. So the algebraic definition of an odd number is 2n plus 1, or some version of this, because 2 times n, 2 times any number, is an even number, isn't it? Any multiple of 2 is an even number. If I then add 1 to an even number, it becomes odd. You could also do minus 1 as well if you wanted. You could do 2n plus 3, or as long as you add an odd number here to the even structure, the even kind of stem, that's fine. But I just go with 2n plus 1. Now then I figure out, what do they ask me to do? What was the calculation? So it's prove that the square of that. So I just need to square it. So like this, which is the same as double brackets, isn't it? Don't just square the 2n and then the 1. You actually have to expand. A lot of proof is just expanding double brackets, actually. So expanding that, I get 4n squared plus 2n plus 2n plus 1. Then you expand and simplify all of this. Don't worry about what we're proving until right at the end. So that's 4n squared plus 4n plus 1. Okay, I've got that far. That would probably already give you 3 out of 4 marks anyway, even if you haven't even proved anything. And then step 3 is, what am I proving? So they're saying it's one more than a multiple of 4. So algebraic proof, normally at the end, you're doing some form of factorising. In this case, I'm going to factorise the 4 to prove it's a multiple of 4. I'm going to factorise that out of just the first 2 terms. So 4 brackets n squared plus n, and then I'm left with a plus 1. Do you see how that is one more than a multiple of 4? Because it doesn't matter what's in my bracket. If I multiply any number that exists by 4, it is a multiple of 4, isn't it? And then if I do that plus 1, then it's obviously one more than a multiple of 4. So that would be your kind of conclusion there. Okay, so we've got here what I'd call area with algebra, or some kind of shapes geometry with algebra. So here is a shape with all its measurements in centimetres. The area of the shape is a centimetres squared, and we need to show that a is 2x squared plus 24x plus 46. So basically, find the area, and we should end up with this, is what they're saying. So this is a compound shape, first of all. So I'm going to break it up. You can either break it up vertically down here, or horizontally across. I tend to go across. So I've got 2 rectangles. The area for the top rectangle would be 4 multiplied by x plus 1, because I know obviously area of a rectangle is length times width, plus the area of the bottom rectangle, which I've got 2x plus 6, but I don't have the width. So you have to use the 2 other vertical sides they've given you. See how this one was 4, and then this whole one is x plus 11. So my third side there must be 4 plus this one must equal x plus 11. So this one here would be x plus 11 minus the 4, wouldn't it? Do you see how that would give you x plus 7? So you just have to figure that out if it's missing, okay? So then we've got, for the bottom rectangle, double brackets, 2x plus 6 multiplied by x plus 7. Now, if you had broken it down vertically, you might then have to figure out one of the horizontal sides in a similar way. So now I'm just going to expand and simplify everything, and hopefully I'll end up with what they gave me at the beginning. So we get 4x plus 4 from the single brackets. Then we get 2x squared plus 14x plus 6x plus 42 from the double brackets. Obviously now collect the like terms. I'm going to put the 2x squared first. Then I've got 4x plus 14x, which is 18x, plus 6, which is 24x. And then 4 plus 42 is obviously 46, which is the same as what they've got, so that's enough. Okay, question 15. Sometimes there can be a lot of cones, spheres, hemispheres, but they obviously won't make you work out the pi section. They'll just tell you to leave your answer in terms of pi. So they have to give us the formulas for these because they're not prisms. So we've got the diagram shows a solid shape. The shape is a cone on top of a hemisphere. Just be careful because obviously they give you the formula for a whole sphere. And in this case, we've got a hemisphere, which is half. So just be aware of that. The height of the cone is 10. As you can see, the base of the cone has a diameter of 6, and also the hemisphere has a diameter of 6. So they've done that deliberately as well because obviously all of our formulas use the radius, and they've given us the diameter. That happens quite a lot. There's already two things here that can trip us up. So the total volume of the shape is k pi centimeters cubed, where k is an integer. We need to work out what k is. So we're not working out the pi bit. The pi will just stick at the end. So I need to know the volume of both. The easiest one to start with would obviously be the cone, wouldn't it? So the volume, I draw it, of the cone is 1/3 pi. Now, again, be careful, r squared. So not 6. You might want to rewrite it just so that you remember on the diagram. Is actually 3, isn't it? Half of 6 is 3. 3 squared, and then times by the height. Now I'm just going to multiply all of that and leave the pi at the end. So we've got 3 squared, which is 9. Times 10, which is 90, and then 1/3 of that. So that's just divide by 3, isn't it? Do you see how that'd be 30 pi centimeters cubed? Then the volume of the hemisphere, again, remember it's half of this formula, is the sphere, which is 4/3 pi. Again, r is 3, not 6. But then remember, you do need to half that. We don't want the whole sphere. So we've got 3 cubed, which is 27. Then you've got 4/3. So 27, you would divide by the denominator. So 9 times by the numerator, 36, divide by 2, 18. However you want to work that out, as long as you get 18 pi. So then the total volume is obviously 48 pi, but they've only asked for the k bit, the coefficient, which is the number bit, which is 48. Okay, another really good one for non-calculator is converting recurring decimals into fractions. So express 0.418 recurring as a fraction. So I always say, if they haven't already, let x equal to whatever your decimal is. Now we need to isolate the part of the decimal that's recurring. Do you see how the 4 is not recurring? It's just the 1 and the 8. So in this case, I'm going to need 10x first of all, because that will move the 4 into the units column and leave me with just 1/8 recurring. But you do need two versions of this. So I can't use x in this case because, again, it's not just got the recurring decimal, it's got the 4 as well. So I need another version. But I can't just use 100x because timesing it by 10 again would give me 41.81 recurring. Do you see how that's not the same decimal? It needs to be the same order as well. So I would have to multiply by another 100, which makes it 1000x on the left. And then 418.18 recurring on the right. See how those two, I'll move those out of the way. There you go, just focusing on these two. See how they both have the same recurring decimal. Now you might find it easier if you literally line them up. So then once you've figured out which versions of 10x, 100x, 1000x you need, we're then going to subtract the two equations. So obviously this side would be 990x, and the other side, the whole point is that it would cancel out the recurring decimals. So then I've just got 418 minus 4, which is 414. And lastly, I'm going to solve it. So get x on its own again. And I've got this fraction. Now they haven't said to simplify it actually, but obviously you could. We could divide by 2. 207 over 495. But I think they would accept either based on the fact that they didn't tell you to simplify it. So in this case we have double proportion. If you can do this one, you can pretty much do them all. So we need to have memorized our formulas for direct and inverse proportion to start with. All of the proportion questions pretty much are in 3 steps. The first step is to write down the formula. So for this one, we obviously are going to have 2. Y is directly proportional to the square root of t. So direct proportion is normally y equals kx. That's the structure, isn't it? In this case, I'm going to use the letters they've given me. So in the order, y equals k times not just t, but you have to input whatever they've told you, which is the square root of t. And then technically for the other one, t is inversely proportional to the cube of x, so that's x cubed. Inverse proportion is normally y equals k over x, and again, just related to the letters. So in that order, t is equal to k. Well, because we've got 2 relationships, I'm technically going to use a different letter for k, because obviously k is not the same for both. but I don't think they'd really mind if you did use k twice. So I'm going to use c, but that represents the k, right? Over not just x, but x cubed. So again, copy what they've given you. That's step 1. Step 2 is then to use what I call the matching pair to find k, or in this case, c. Do you see how they've given us y is 15 when t is 9? So sub that in, make sure you put them in the right way around. So 15 equals k over root 9, which is the same as 3k, isn't it? For k, you can find out what k is by just dividing by 3, which is 5. So I'm going to rewrite that equation. Y is equal to 5 root t. That's the actual relationship between y and t. Same with the other one. We've got t is 8 when x is 2. So 2 cubed is obviously 8. And then we need to multiply by 8 in this case to get c on its own. 64. Do you see how they're different numbers? They're not the same. So therefore, if I write that relationship again, I've got t is equal to 64 over x cubed. Now I've got both formulas, both relationships, having found out what k is. Then we can answer the question. In step 3 in this case is to find a formula for y in terms of x. Normally the step 3 is some kind of substitution. In this case, they've said y in terms of x. That means y equals, y is the subject, and everything else, there are obviously numbers, but everything else is in terms of x. So we don't want a t. But do you see how t is in both equations? So all I need to do is substitute the second equation into the first one. So instead of root t, it's going to be root 64 over x cubed. The whole of that is rooted. Now they have said give your answer in its simplest form, so I am going to root some of that fraction. Obviously I can square root 64 to get 8. I can't square root the x cubed, so I'm going to leave it as the square root of x cubed. And then the 5 is technically 5 over 1. I'm going to multiply it in my numerator. So I should get, for my final answer, 40 over x cubed. So the function f is given by f of x is 2x cubed minus 4. We need to show that the inverse function when x is 50 is equal to 3. So we need to get 3 as our answer. So first of all, going to do the inverse function, then I will sub in 50. So I need to write down, just for now, y is equal to 2x cubed minus 4. Some people like to swap the x and y immediately. I tend to do it at the end. Doesn't really matter. So I'm now going to make x the subject. So I'm going to add the 4. I'm going to divide by 2, and then I'm going to cube root. Obviously, you can do this in more than one step, but I'm just going to write it like that. And then obviously for my inverse function, I need to swap it back. I don't actually want y, do I? So x plus 4 over 2, the cube root of that. So that's my inverse function. Now, do you see where my x is? They've got 50. So that means, obviously, when x is 50. So I'm going to sub in 50 for x. So cube root 50 plus 4 over 2. So obviously then work that out. 50 plus 4 is obviously 54. Over 2 is 27. So we've got, you can see how many times this number has come up. If you don't know the cube root of 27 by now, then I don't know what you're doing. It's 3, isn't it? And they said show that it's 3. Well, I've got 3. There was also a part B, so the functions g and h are given by g of x is x plus 2, h of x is x squared. Find the values of x for which we've got a composite function. So this one is a little bit, I think this one's a little bit harder to interpret. This is not that we're going to find the composite function and show that it equals this, because it doesn't. They're saying find the composite function and then put it equal to 3x squared plus x minus 1 and then solve. So that's why it's 4 marks. So first of all, I'm going to find the composite function. Now composite functions always sub in backwards, as in I'm going to sub in the g into the h, depending on which order they've obviously listed the letters. So hg of x is sub the whole of g into wherever there's an x in the h function. So all of that would be squared. And then they've said that is equal to 3x squared plus x minus 1. So now I can almost forget about my functions and just go, right, okay. Again, this is double brackets, isn't it? That is equal to 3x squared plus x minus 1. And I just need to now solve this. So expanding, obviously I'm going to get x squared plus 2x, which is 4x, plus 4 is obviously equal to the other side, still 3x squared plus x minus 1. Now, because I can see that I'm still going to end up with a quadratic overall, and they've obviously said values, plural, of x, I'm going to move all the terms to the side of the equation where x squared would remain positive. So I'm going to move, in this case, all of the left to the right, because if I take away x squared, I still have positive 2x squared, don't I? That's how I decide. So all of those to the right, so 0 is 2x squared x minus 4x is minus 3x, and then minus 1 minus 4 is minus 5. This is what we now need to solve. So normally we would go ahead and try and factorize, obviously 2x and x, and then solve from there. So you should get x is positive 5 over 2 or minus 1. So that's our values of x. Solving simultaneous equations, but graphically. It could be two linear ones, two straight lines, it could be a circle and a line, or any kind of combination of two graphs. So the diagram shows the graph of x squared plus y squared equals 30.25. You don't really need to know that, that's just the circle they've drawn. Use the graph to find estimates for the solutions of these simultaneous equations. Can you see how the first one is obviously the circle they've drawn? And then the second one, you should be able to recognize this, is a straight line. I know they've rearranged it, but it's linear, isn't it? Straight line. So I'm going to rearrange that first, and then we obviously need to plot that one because it's not there, is it? So I always like to have it in the format of y as the subject, y equals mx plus c, 2x plus 1 in this case. Now you only need to plot two coordinates and then join them up with your ruler. The first one I find is really easy. I just use whatever number at the end. That's our y-intercept, isn't it? So plus c, that's the y-intercept, which is here. And then I'll choose another value, so for x, make sure you obviously don't choose something that's too big that goes out of the graph. So maybe, I don't know, when x is 2, for example. Do you see how if I sub that in, 2 times 2 is 4 plus 1 is 5. So I have the other coordinates, 2, 5. 2 and then up to 5, where's that here? Obviously then get your ruler, draw a line, but extend it the whole way through the graph. So something like this. That's the line that was missing. Now all we need to do is check where they intersect. You see how we're going to have an x and y value here, and an x and y value here. So the first one, now you only need to do it to like one decimal place. I would call that probably 2.1. I know it's not 2 because it was 2.5 and 2.5 is not on the circle. So that's why I'm going with 2.1. And then the y is just above 5, isn't it? Again, just double check the scale. It could be different scales. In this case, it's not. So I'm going to go with 5.1, maybe 5.2. I think I'll go with 5.2 for that one actually. They will have a small possible range of answers because, again, you're drawing the line yourself, so even if you haven't done it super accurately, you could obviously have a slightly different answer to everyone else. And the second one, I think, is probably about minus 2.9-ish. And also don't forget if they have negatives as well. Minus 4.8 maybe. And then just list them over here, obviously showing which is x, which is y. So x is 2.1 or minus 2.9. Y is 5.2 or minus 4.8. So you might have to draw one of the lines, but beyond that, it's quite straightforward. You're just checking where they intersect. Okay, our final question is obviously going to be surds. So here we need to write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form a root 3 plus b over c, where a, b, and c are integers. When they ask you this question, they haven't said the words rationalize, but it should be implied because you see how we've got surds in the denominators originally, and then no longer in the answer. So we're going to rationalize both. Now, this is quite a good example because you've got two different types of denominators. You've got one which has two terms. You see how you've got a 4 and then minus root 3. And the second one, which is easier, which just has a surd. So there's slightly different ways to rationalize them both. So 3 root 3 over 4 minus root 3. This one you're going to multiply. Obviously we multiply the top and the bottom of the fractions just anyway, don't we? That's how fractions work. But you're going to multiply it by the denominator. You have to make sure you change the symbol though. So plus in this case. Because we want to create a difference of two squares scenario. Because if you remember a difference of two squares, that's where the middle terms get cancelled. So that's that first bit, and then you've got technically minus 2 over root 3. That one, all you need to do is just multiply. If it's got only one term, and obviously that term is a surd, the top and the bottom by that surd. So that's a bit more straightforward. So the first one is kind of like expanding at the top, single brackets, at the bottom, double brackets. So you can rewrite it like that if you find it helpful. Just be careful when you're multiplying with a mixture of whole numbers and then surds, and not to mix them up. So the first one is 3 root 3 times 4. That's just a whole number, so that's only going to affect the numbers on the outside, so that's 12 root 3 still. And then you've got 3 root 3 times, let's actually draw the lines, shall we? Times root 3, so that's only going to affect the surd, so you've got plus 3. Now technically that's root 9, isn't it? Or you could obviously just write it straight away as 3. Over, and then this bottom bit, the whole point is that it cancels out. So 4 times 4 is obviously 16, which is fine, that's a whole number, so that's fine in my denominator. 4 times root 3 is obviously 4 root 3. But then do you see how now I've got minus root 3 times 4, which is then minus 4 root 3. So the whole point is that those surds will obviously cancel each other out. And finally, just be careful because that is a negative, minus root 3 times root 3, so that's minus root 9, which, because that's a square number, the surd will cancel itself out anyway because it will become a whole number. And then over here, we're going to have, obviously, the numerator, 2 root 3, can't mix them because one's a whole number, one's a surd, and then technically root 9, which again, as we said, should square root. So now I'm going to go through and simplify again. I've got 12 root 3 plus, now the root 9 obviously square root, so that becomes 3 times 3, which is just 9 as a whole number, over, now these middle bits cancel, so I end up with 16 minus, and then this is root 9, which is obviously square roots to become 3, take away 2 root 3 over, again that's square roots to become 3, so if I come over here I get 12 root 3 plus 9 over 13, if I subtract those, minus 2 root 3 over 3. Now, the last thing though is they've obviously got a single fraction, not two fractions, so we're going to have to actually subtract the fractions, which is now just more fractions than anything. So we need to find a common denominator between 13 and 3, which unfortunately is just those two multiplied together. So I need to multiply the first fraction by 3, numerator as well, so 12 root 3 times 3 is obviously 36, the root 3 stays the same, plus 9 times 3, which is 27, that's over 39, and then minus, this one I have to times by 13, so 2 times 13 is obviously 26, again the root 3 is not affected because it's a whole number, over 39. Now I can actually subtract them, but do you see how I've got 36 root 3 and 26 root 3, they're both something root 3, so I can subtract those like as if they were like terms if you think about algebra. So that's 10 root 3, and then obviously the 27 is still there, over 39. Check if you can simplify anything, but it should be between all three numbers, so 10, 27, 39. Do they all have a common factor? No, so that would just be your final answer. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and check down below in the description for any other videos that you might find helpful heading towards your non-calculator exam.